Okay, hey there. This is an exciting bit of code where we're going to begin to play music. Okay, so here I would recommend naming it tone. Okay, because we're going to use the tone command, and just pause the video here, enter the code, and then unpause it when you're ready. Okay, so you've typed all the code in, which is great. And if you followed along in the previous videos, we were using a piezo buzzer in the previous videos. So I'm just going to run the sketch here with the buzzer attached, which it's not meant to drive a buzzer. So let's see what it sounds like here. Okay, the piezo buzzer is meant to drive at one frequency. So when it sees a voltage, it just puts out that frequency no matter what you do to it. So the tone, what it's doing is it's trying to drive that audio pin at a frequency of 512 hertz, which is the same note as middle C, and it does it for a duration of 1,000 milliseconds or 1 second. Okay, so the piezo buzzer is not meant to be driven like this. So I'm going to remove it. Okay, and I'm going to install an audio transducer. So the piezo buzzer in your kit probably has a little piece of tape on the top, a little sticker on top. So remove that, and instead look for something that looks just like it, but there's no tape. One other way to tell them apart, if the tape has already been removed, is the audio transducer will often have wire leads of the same length. But it's important to remember which one is positive, as you can see here on the top. This guy is positive, so that gets plugged into pin A0 here, and the other goes into ground. Okay, can you see that? Let's see. Okay, so I'm plugging one into A0 and the other into ground. It's kind of hard to see, I apologize, but there it is. Easy thing to do. Push it in, and now we're ready to go. So let's run this code with the audio transducer. Okay, a much smoother sound here. So we can change this effect, we could make it be a higher pitch, maybe 900 hertz. I'm not a musician, so I don't know what that corresponds to. Okay, a much higher frequency, or we could try 300 hertz. Much lower frequency, and we can change the duration. Okay, for about half that time. So half a second at 300 hertz, whatever that is. So I'm going to take it back to middle C, which is 512, and we can play that for half a second. Now, we should look at the timing of this. Okay, so I'm going to open up the serial monitor, and when I run the code, watch what happens when on the serial monitor and listen for the sound, and let's see about the timing here. Oh, maybe. Okay, so it's rerunning it again. Let's just make it be 1,000 here. Let's see what happens. Watch it over here. So the test concluded popped up well before this was done playing. Okay, so I want to add another piece of code here. I want to add tone, and then So I want to add another piece. So I want to add another piece of code here. I want to add no tone, another command. Okay, and we're going to send this to the audio pin. Right, and this will produce no notes. So listen to this and watch the serial monitor. Listen to the timing of it. Okay, you didn't hear anything, because what happens is it tries to play the audio note, and then immediately it plays the next line. So this line, or this delay here of 1,000 is not really a delay. Okay, and so if we want it to actually play the full duration, we need to add a delay here, and this delay duration and this play tone duration needs to be the same if you want it to play the full 1,000. So this is screaming for this to be a variable, right? Because it's the same value every time. Okay, and then it shuts off the tone. So if we want this to be for 750 milliseconds, then this also has to be for 750. Again, this would be good to be maybe in its own function or a variable that you change the variable once and it changes both values. Okay, does that make sense there? All right. So before we put this guy to bed, let's just look at a new piece of code that I've added here while I pause the video. All right, so we've got a little string printing to the screen. Let's make some noise. Prints a blank line. It delays for 750 so you can read it. And then it says print allow noise in 3. Okay, so this is going to give a 3000 hertz signal sound on the tone generator for 10 milliseconds. So it's going to be a little beep. Okay, and then it's going to delay for 1000 and then print 2, do the same thing, print 1, do the same thing, and then it's going to say the word now, and then it's going to play the audio pin. Okay, again, this value and this value need to be the same. Here I'm just doing beep, beep, beep. So these two delays don't have to be the same necessarily. This is just a beep and then delay for a second, beep, delay for a second, beep, delay for a second. All right, and then again, look at the serial monitor and watch the code happen. Here we go. All right. So this is one way to use the audio transducer to make music. In the next video, I'll show you actually how to play musical notes from some childhood songs. You know, Mary Had a Little Lamb or Twinkle Twinkle Little Star or something like that. All right, so that's the next lesson.